we'll be finishing off solving our quadratic equations by talking about how to choose the best method. So we talked about 5 different methods. Graphing will always work to give approximate solutions, and you can quickly see the number of solutions, but the disadvantages to graphing is you can't always get an exact solution, and it doesn't show imaginary solutions. So graphing, that's why we kind of stay away from it for the most part. Factoring has some advantages. It's always good to try it first, and it's straightforward if it's factorable, but not everything is factorable. All right, and it could be complicated if you're dealing with some pretty big numbers. Square roots, its advantages, quick when the term has no x term, right? Nothing with a bx, but you can't use it otherwise, right? So as long as there's a term with an x without a power to it, right? If there's an x squared and an x, you cannot use square roots. Completing the square, great because it always works, but we really only want to do it when b is even and a is 1, right? It's very difficult to do when b is odd or a is not 1. Using a quadratic formula, that's fantastic because it always works and you can always find exact solutions. But other things may be easier to do. So what I would do is I would be checking what is the best scenario for each one, right? So if a is 1 and b is even, the best thing we can do is complete the square. Which I'm going to abbreviate for, I'm going to be making a little chart for these. CS for complete the square. If b is 0, right, there's no regular x term. It's just an x squared and a c. Or if it's written in vertex form, that can be square roots. Right, I'm going to say SR. If the discriminant is a perfect square, so we didn't talk about this, but if you find the discriminant and it's a perfect square, that means it is factorable. So I would factor that, right? If it doesn't fit one of those two things, I would check my discriminant to see if it's factorable. If you have access to graphing software, then yeah, graphing is the way to go, right? But again, we're not going to really worry about that one too much. Any other circumstance, it's going to be quadratic formula. Okay? So for each of these, we're going to use a different method. So for example 1, right now I have 2x squared plus 5x, and if I move this over, plus 3 equals 0. And out of my choices of complete the square roots, factor, and quadratic formula, a is not 1. I'm not going to complete the square. I have a b term, so I'm not going to do square roots. So it's either factoring or quadratic formula. I'm going to use my discriminant to choose between the two. So the discriminant would be 5 squared minus 4 times 2 times 3, right? b squared minus 4ac. So 25 minus 8 times 3 is 24 equals 1. 1 is a perfect square. That tells me this is actually factorable. So if I'm going to factor this, we know we're going to do 2 times 3 is 6. 2 plus 3 is 5. So this is going to be rewritten as 2x squared plus 2x plus 3x plus 3. And we're going to do grouping. 2x comes out of those. 3 comes out of those. So we're going to get x plus 1, 2x plus 3. So solving each of these, x plus 1 equals 0, x equals negative 1, 2x plus 3 equals 0, x equals negative 3 halves, or negative 1.5. All right, so I chose to factor on this one. For example 2, I'm going to make my list, right? Complete the square root, factor, quadratic formula. A is 1 and b is even. So I'm going to complete the square for this one, which means I actually want to move the 100 over this way. So this is going to be x squared minus 12x equals 6 minus 100 is negative 94. So remember here, we take the b term, cut it in half, and square it. So that's a negative 6 squared, oops, which is 36. So we're going to do plus 36, plus 36. So factored, this is x minus 6 squared equals negative 94 plus 36 is negative 58. So now I can square roots. X minus 6 equals plus or minus square root of I times square root of 58. 58 does not reduce. So then all we have to do is add the 6. 6 plus or minus I root 58. For 3, complete the square root, factor, quadratic formula. So A is not 1, complete the squares out. I don't have a B term, right? There's no regular X in this, so I'm going to be doing square roots. So I'm going to minus the 2. I'm going to divide both sides by 9. And then I'm going to take the square root. So X would equal plus or minus square root of 47. That one doesn't go any further either. All right, example 4. Make my little list. Well, we've already used 3 of the methods. You could probably guess what we're going to have to use this time. A is not 1, so complete the squares out. We have an X term, so square root is out. Let's go to our discriminant. So that's going to be b squared minus 4ac. So that's 64 plus 8 is 72. That's not a perfect square, so factoring is out. We're going to do quadratic formula. What's nice is we've just done some of the work for our quadratic formula. I now can go and say x equals negative b plus or minus the square root. I already did b squared minus 4ac, so that number can just go under the square root, 2a. All right, and it feels a lot less daunting now. So now this is a positive 8 plus or minus, so the square root of 72 is 36 times 2, so 6 root 2. Also remember, when we're reducing this, we can only divide by what goes into everything. We ignore the root, but everything else. So everything else 2 can go into. So 4 plus or minus 3 root 2 over 2. Our last one here, we're going to repeat one of the methods. This one looks like it's vertex form. So this is a square roots problem. So square roots means I'm going to move that over to get what's being squared alone. So we add 15 to both sides. Now I could take the square root. So the square root of negative 75, 75 is really 25 times 3, and we have the I because of the negative 1. So we'll have 5I root 3, and then minusing our 12. There we go. So for the last 4 here, you're going to try them on your own. You should be using a different method for each one. Answers are posted in the blank notes of Google Classroom. And that is it for choosing the best method.